So g'day fellow geology buffs, and here I am at the Murrundindi Rapids. This is in the Black Ranges, and the Black Ranges is mainly just granodiorite. Sorry, what am I talking about? Granodiorite, so it's in between granite and diorite. It has a silica content of about 63 to 69%. And if you see the actual rock, you can see how it's actually like rounded. So this typically is how granite erodes. So it is actually really rounded, and over there as well. So this is more like onion exfoliation. And behind me you can see the actual rock rounded. It looks like it has large crystals. So this actual rock was formed underground as a batholith. So it's an intrusive igneous rock. Means, intrusive means it's under the ground, and it's probably late Devonian. So it's about 370 million years old, this actual type of rock. So now other places I actually see this is Quarry Hills in South Marine, Woodlands Historical Park, that's near the airport. So that has definitely this type of granite. I think that's just granite though. I need to make a video on that actual geological feature over there. So all this is actually granodiorite. Surrounding it, we actually have, to the south, we have rhyolite, which is the extrusive equivalent of granite. The extrusive equivalent of this, I believe, is from memory, is dacite. I didn't actually bring any, but hopefully I can actually get a good rock to actually take home. And let's see if we can find any other ones. So we've got some more down there. Got a large rock here. Got some more rocks over there. Got another one over there. But a lot of it is covered in moss. So the erosion process is actually quite slow, it looks like it. I don't see any fresh rock around here. Let's have a look and see if we can find some fresh rock. So behind me you can see we have a lot of the rapids. This is all granodiorite rock. Down here we have a lot of granodiorite, and you can just see that rapids there, so beautiful. A lot of granodiorite just along there. So this is probably where a fracture was, or maybe the fracture was downriver, and has actually worn the actual rock from this way and is eroding in that upstream. And you can see a lot of the actual fractures. Now, okay, so here's a fracture there, where the actual water is actually going through. There's a large fracture going along there. And you can see there is where that rapid is there. It's actually a large fracture right there. So, and there's one going around there. Whoop, and it's coming down that way. So that's another fracture. And that's how the actual rock will get eroded, through those fractures. And then it just slowly eats into the rock, so it actually gets smaller and smaller and smaller. And it's eroding it all the way upstream, because this would have been part of a mountain building process. So the batholith would have come in, the rock would have been pushed up. The sedimentary rock on the top, or even rhyolite, could have been rhyolite. It would have been eroded a long time ago, and it's eroded all the above rock until it gets to the batholith, and now it's actually eroded and evaporated. So eventually, sometime in the future, definitely in 50 million years, this batholith will be gone. There'll be nothing left of it. Except specimens that collected it and are in a space museum on Mars somewhere. So, I hope you can actually hear me. Very loud. Beautiful and loud. So here I actually have some rock. This is the actual rock of the area. So this rock here, that's actually at the park, it actually looks like granite. So this is actually not the original rock here. This one's actually got towards the actual creek. And you can see it actually has large crystals. So if so here, there, that black crystal there, that's mica. So that's actually quite a large mica crystal. We have white, which is the feldspar. The greys would be the actual quartz. And not too sure what type of feldspar it is. Need to actually have a mineral composition. Could be potassium, could be orthoclase, sodium feldspar, or calcium feldspar. I would say the composition is probably in between those three. Could be a third of each, you don't know. And looks like up the top we actually have a large crystal of quartz. So that is the actual country rock that's actually here. So let's have a close up. No, I'm gonna have to make another video so we can actually have a close up of the actual rock. So this doesn't focus actually quite that good. So here we have the two actual rocks. So this is the actual granite. It probably comes from somewhere down south. And here we actually have the granodiorite. So you can see there's large pink crystals. Does it look pink? It looks dark anyway. I need to actually get some good light on that. So you can see that the black is actually mica. Then we have, looks like the other black stuff is probably pyroxene. Then we have large crystals of granite. See, this actually looks very fine grained, salt and pepper. And then we have some more crystals. So I'll take this home and then we'll actually see what type of rock it is. So this is actually an intrusive igneous rock, as I've been saying. It is fine grained because it actually grow probably cooled pretty quickly. If it's coarse grained, then it would have actually cooled pretty slowly. So with this rock, it's actually called, oh, I can't remember what it's called. I think Black Mountains rhyodacite. No, Black Mountains granodiorite. Gee, I keep on getting confused between the two. So granodiorite of the Black Mountains. This rock in the center of it's supposed to be really more like gneiss, so it's striated because it had time to actually separate into the different minerals. In the edges it's more like rhyolite, so it's actually very fine grained, and this one actually looks like the rhyolite composition. So, and you can see the granite actually has large crystals, so it's like a large crystal of white mica, and then you got hornblende, looks like feldspar, and then you got quartz. So they're the four crystal systems that you can mainly see in that. And this one you can see, you can't actually see that. You can see the actual mica, but that's about it. So anyway, put this video together, and I hope this helps you with the actual geology of the Black Ranges. As you can see, as you go towards the actual creek, which is that way, you can actually see some of the geology, but around here you can't see any. So you have to go towards the water courses to actually see the geology. Thank you, and goodbye.